All right, this video is just going to be me doing every single question on the study guide. So feel free to rewind or fast forward as needed. So here we go. Question number 1, convert the angle 60 degrees to radians. So remember, whenever we're converting to radians, we just take our angle, 60 degrees, and we just multiply it by our conversion factor. If we want to go to radians, it's going to be pi radians over 180 degrees. If I was going to degrees, it would just be the reciprocal of that, which we're going to do over here in a little bit. When I do this, I'm just multiplying, but I can definitely reduce. I could definitely cancel out degrees. I could take a 10 out of both of these. And then what's left? I have a 6 on top and an 18 on bottom. Well, I could take a 6 out of both of these. If I take a 6 out of this, it becomes 1. Take a 6 out of this, it becomes 3. So at the end of the day, I have pi third radians. So let's recap. I just take the angle I have, I multiply by my conversion factor with radians on top, with the thing I want on top. So if I wanted degrees, I would just flip this and put degrees on top. And I multiply across. This is really just a reducing problem. You could think of this as this division line. You could just think of it going all the way across, and you're just reducing. So there's your answer. All right, number 2. In a circle with a radius of 14 and an arc length of 21 pi halves, what's the measure of the corresponding central angle in radians? Key thing is in radians. So really this is an arc length question. I'm going to write that down. This is arc length in radians. Well, I gave you the flux capacitor for this, okay? Looks like this. Where theta is your central angle, S is your arc length, and R is your radius. What do they want? What's the measure of the corresponding central angle? Okay, so they want central angle. I want that. If I was to cover this up, I'd have S over R. So my formula is simply theta equals S over R. S here is 21 pi halves, and the R is 14. All right, here's what I told you, though. Anytime you have a fraction divided, let's clean that 2 up. It looks a little bit tricky. That's a 21. Anytime you have a fraction divided by another number, you're really just multiplying these two denominators together. It's like dividing by 2 and by 14. So this is the same thing as 21 pi over 2 times 14. Well, you can multiply it together or you could reduce right away. But let's say you just multiply together, you'd get 21 pi over 28. And hopefully, see, you could take a 7 out of both of these. You take a 7 out of this, you get a 3. Take a 7 out of this, you get 4. Because that was a 28. And what does that make? That makes 3 pi fourths. And that's in radians. As long as we followed this formula, we have our answer. Cool. All right, let's go to number 3. WZ and XR diameters. Find the measure of ZWX. Okay, let's first make sure we know what we're talking about. This is an arc measure of ZWX. So start at Z, go through W, and then to X. So what we're talking about is this arc right here. And when they say measure, measure is the same thing as an angle. So it's just an angle measure. So really, they're kind of saying the same thing as this angle right here. Now let's think about this. This, if I just did, I'll do this in blue. If I just did this arc, that's exactly half a circle. So that's 180 degrees. Where this one is 39 degrees. So the arc that I'm looking for, ZWX, is 180 plus 39. So that's 219 degrees. That's all you're doing there. Okay, let's go to number 4. All right, convert the angle theta equals 37 over 36 pi radians to degrees. Okay, so just like I did over here on number 1, except for on this one, I was converting 2 radians, and now I'm converting 2 degrees. So since I'm converting 2 degrees, I take my 37 pi over 36, and I multiply this by 180 degrees over pi radians. This is already radians. This is radians. So radians obviously cancel out, and the pi symbol can cancel out because you have a pi on top and bottom. So what do we need to do? We need to reduce this further. Basically, I have a 180 and a 36. I'm going to reduce here. I can't reduce here, but I can reduce here. And it turns out that 36 goes into 180 exactly 5 times. So I can take a 36 out of this, make it a 5. Take a 36 out of this, make it a 1. What am I left with? I'm left with 37 times 5. What is 37 times 5? I'm going to go to my calculator because I don't know it off the top of my head. We get 185. So when I multiply 37 by 5, because that's all that I have left, I get 185 degrees. Okay, so I just multiplied my conversion factor, which is 180 degrees over pi. Again, I did degrees because I want to go, I did degrees on top because I want to go to degrees. Round number 1, I did radians on top because I wanted to go to radians. So when you have to convert, ask yourself what you're trying to get to and put that on top. All right, it says use the diagram above, or use this diagram for question 5. Let's see here. In the circle above, AB is 4 inches. Put a little 4 right there. Find the arc length of BC. Okay, the arc length of BC. So they want this distance here. Length is different than measure. If you remember, arc measure just has to do with an angle amount or a degrees. Arc length is distance. It's like laying a string on this and telling me exactly how long it is. Well, this is 4 inches, so our length here should be in inches. Well, if only there was a formula for arc length when everything's in degrees. Hey, wait a second, there is. It looks like this. Theta over 360 equals S for arc length. You could also see L for arc length over the circumference, which is 2 pi r. All right, well, we actually know what our radius is. They told us to it here, so I'm going to plug that in. And we can figure out what our central angle is, because this is a straight line, so these two angles have to add up to 180. So if I just do 180 minus 38, I get this central angle right here of 142. So plugging everything in, I got 142 degrees here over 360 degrees equals S, which is what I'm trying to find, the arc length. And then on the bottom, if I plug in a 4 for radius, I would get 4 times 2, which is 8. So I get 8 pi. Don't forget about the pi symbol. It needs to stay there. Now, what I like to do is reduce. I like to reduce if I can. And I see right away that I could probably take a 2. I know I could take a 2 at everything because they're both even. But I'm wondering if there's something more I could take out. Well, let's just start with a 2 and see what goes from there. It's not coming to my head right away. So if I took a 2 out of the top, 140 divided by 2 is 70. A 2 divided by 2 is 1, so that's 71. And 360 by 2 is 180. No, I don't think that I do have anything that I can reduce that any further. So what do I need to do now? Well, now I need to get S all by itself. We can see that's what I want to know. That's the arc length, S. Oh, let's do it in blue since that's what I did. That's what I'm trying to find. Okay, well, what do I want to, I want to know what S is, so I'm going to multiply both sides by this 8 pi. The reason why I'm doing that is that makes these things cancel out, and now over here I have S all by itself, so I just have to deal with this problem. And I can definitely reduce this. I know that 180 is divisible by 4, and so is 8. So I'm going to start there. What happens if I take a 4 out of this? That becomes a 2. Take a 4 out of 180, that becomes 45. That doesn't reduce anymore, but I think we have an answer now. So let's see what I got. I have a 2, I have a pi, I have a 71. So 2 times 71, hey, we're back to 142, is 142 over 45. And don't forget about the pi. And remember, this is all in inches, so I could write inches. And by the way, you could put the pi on top, or you could write it like this, 142 over 45 pi. That's your S, or your, that's not a 5, that's an S, which is what we use for arc length in these problems. Also, you could use an L. I mean, really, you can use whatever letter you want, as long as you know what it means. You can use a smiley face, it doesn't really matter. Okay. There's my answer. I don't believe that reduces anymore. I'm going to check my calculator real quick just to make sure. No, it doesn't reduce any more than that, so we're good. All right, let's take a look at number 6. The key thing that I want you to recognize in number 6, the first thing you should recognize just by looking at it, is you should see that angle B here, as you were to follow it out, it intercepts exactly half of a circle. So that's 180 degrees, which means that this has to be a 90-degree angle. Well, in a triangle, all these angles have to add up to 180. So you should be able to say pretty easily that 180 degrees is equal to angle 1 plus angle 2 plus that 90 degrees that we just marked. But what I would do before I even start plugging in 1 and 2 is I would just say, you know what? I don't really need to do this equal to 180. I could just, and you could probably just do this part in your head. I'm just going to subtract 90 from both sides, and I'm going to get this new equation. I'm going to get 180 minus 90 is 90, so therefore angle 1 plus angle 2 has to add up to 90. All right, well, what is angle 1? Angle 1, they tell us down here, is 7x plus 6. So I'm going to replace that. Angle 1, 7x plus 6. What is angle 2? They tell me it's 21x, so I'm going to do plus 21x. And now I have a really basic algebra equation here. That's a plus there. So let's go ahead and solve this out. I got 90 equals, I can combine the 7x and the 21x to make 28x plus 6. And remember, with algebra, you're always trying to work from the outside in. So what I would do here is I would subtract 6 from both sides. That gives me 84 equals 28x. And now I want to divide both sides by 28. And so now I just need to know what's 84 divided by 28. And it turns out that's exactly 3. So x equals 3. Now that is not the answer to this question. Very easy for students to just go, oh, yeah, the answer is 3 and think that they're done. But that's not it. What do they want? They want you to find the measure of angle 1. Well, to do that, you're going to take this 3 and you're going to plug it back into angle 1. So what does that give you? Measure of angle 1 equals 7 times 3 now, because we know that's 3. Plus 6, that's 21 plus 6. 21 plus 6 is 27. So that's the answer we're looking for there. All right, let's go to number 7. 7 is a very interesting question. I have a question similar to this, where really what I'm looking for on this question is, can you explain your reasoning? It could be in a sentence. You could try to write a 2-column proof, but can you explain your reasoning to me? That's what I'm looking for in this question. So using all of our properties that we've learned, can you explain your reasoning to me on how you find your conclusion? So let's go through this one, and I'm going to kind of walk you through what I do. A lot of times what you're going to do on these types of problems is you're just going to write down everything you know. Some things that you know or can conclude are not relevant to the answer. If you look, they want the measure of angle BCE. Let's just mark that. That's this angle right here. So at the end of the day, I'm trying to find that angle. Well, maybe I'll find some other information, and maybe it's not actually going to be relevant to BCE, but that's okay. I could still add it to my explanation. It's not going to make me lose points, but at the end of the day, I need to be able to demonstrate how I know what this angle is. So I need to find it, and I need to be able to explain how I found it. So what would I do first? I would just start marking what I know. They told me right up top that in circle D, AB is congruent to CB. So we know this distance is congruent to this distance. And we know that the measure of arc CE is 40. So let's do CE right here. That's 40 degrees. All right, well, I can conclude quite a bit from this. So given that these two segments are the same, we actually know quite a bit, because if we follow this original angle here, we can see that it intercepts this bottom half of the circle. And so this is 180 degrees, which means this is 90. And so that's a right triangle, and also these two sides are the same. So it's a right isosceles. We actually have a name for this. We know what kind of triangle this is. It's something we've played with a lot. This is called a 45, 45, 90. Again, a right isosceles is always going to be a 45, 45, 90. Because if these two sides are the same, these two angles have to be the same. And if we already have 90 here, that means these two angles have to split another 90 degrees evenly. The only way to do that is 45 and 45. Well, look, we have part of our blue angle here, our BC angle that we're trying to find. I just need this piece. Well, there's a few different ways you could do this part. I think the simplest way is to recognize that, well, we already established that this is 40 degrees. So couldn't we easily establish then that this arc over here, A to E, couldn't we establish that that would have to be 140 degrees? Just because, again, this has to be 180. It's half a circle. So 180 minus 40 leaves us with 140 over here. Well, let's follow that back to the inscribed angle that we want to find. See my ice cream part. Here's my cone. If this is a 140 degree arc, then this angle has to be exactly half of that, which is 70 degrees. Beautiful. Well, if this angle is 45 and this angle is 70, I can conclude that angle BCE equals 45, let's match the colors, 45 degrees plus 70 degrees, which means that angle BCE is 115 degrees. Okay, there's all the math. I did the explanation as I made this video. I explained all my steps. So let's just recap. I would expect you to tell me how you know these in sentences. How did you know these angles were both 45? And again, that's because it's a right isosceles. I would expect for you to tell me how you knew this arc is 140. And again, that's because this whole thing has to be 180. So we can simply do 180 minus 40 to get 140. And then we can know that this is 70. How did you know this is 70? Well, it's half of 140. And then finally, therefore, the angle we're looking for, BCE, is going to be angle BCA plus angle ACE, which is 45 plus 70. And we have our answer. And now I've explained to you all the steps that I would be looking for in this problem. Okay, that one's fun. Probably that one is going to be the most work out of any of the problems here on this study guide. So if it helps you to write down my explanations on a 3x5 card, then so be it. But you're going to want to know that. All right. Let's go to number 8. Number 8. A lot of students get really confused on this one, but there's some really simple things to do here. A few different ways to do it. I'm going to show you two. The first one I'm going to do in blue, and then I'll do the other one in red, okay? First thing I notice is that these are all radii of the same circle, so they have to be the same. Well, that makes this an isosceles triangle, which once again means these two angles have to be the same. Although this isn't 90 now, it's 77. So if all these angles add up to 180, I know these two angles have to add up to 180 minus 77. So I could basically do this. If I was to put like an x here and an x here, couldn't we say that x plus 77 equals 180? Or 2x plus 77 equals 180? So again, these two angles are going to have to share the difference. So what I do is I just subtract 77 from both sides, and I end up with 2x equaling 103. Divide both sides by 2, and I get that x equals 103 divided by 2, which is 51.5. All right, so that angle has to be 51.5 degrees, and that happens to be what they're looking for. It says find the measure of BAC, BAC, BAC. All right, that is one way to do it. The other way to do it, and we'll get the exact same answer, is this. This is a straight line. If this is 77, this angle right here must be 180 minus 77. Look, we already did that math here. 180 minus 77 is 103. And remember, central angles and arcs are the same. So this is 103 degrees. But if we follow this arc back to its inscribed angle, here's the ice cream, here's the cone, the bottom of the cone, this angle has to be exactly half of that arc. Hey, we already did that. 103 divided by 2 is exactly 51.5. So either way, our angle here is 51.5 degrees. So two ways to handle that one. Let's go on to number 9. All right, I love this question because it looks really confusing at first, and it's actually pretty easy to do. First thing that I would note is that this is x, this distance right here from the center to the edge of the circle. Well, we have a name for that. That's called a radius. And this is also a radius right here. So that's also x. And it says right here, assume that segments that appear tangent are in fact tangent. Well, hey, that means this is a tangent line, And we always know that that makes a right angle with the radius at that point. So that's a right angle. That's a right triangle. Okay, well, if it's a right triangle, we know the Pythagorean theorem has to be true. So we could say that x squared plus 12 squared has to equal x plus 8 squared, because this distance here is x plus 8, right? So we have to add it together before we square it. And the mistake that students often make here is they go, oh, yeah, that's just x squared plus 8 squared. No, that's not what that is. Remember, you have to either use the box method or FOIL, or you can use the pattern of perfect squares. I'm going to use the pattern for perfect squares because we did that a whole bunch. We should be familiar with that by now. So to expand x plus 8 squared, you end up with this. X squared plus 16x plus 8 squared is 64. Now, there it is. Now you might think, oh no, this is a quadratic. I got to solve a quadratic. Yes, it is a quadratic for now, but it's actually pretty easy because if I subtract x squared from both sides, look, the x squared just disappear. And you're left with a really easy equation. You get 144 equals 16x plus 64. Subtract 64. 144 minus 64 is 80. So you got 80 equals 16x. Now we need to divide both sides by 16. And voila, 80 divided by 16 is 5. So the answer to this question is 5. No big deal. Easy peasy. Let's just recap. I did Pythagorean theorem, but I had to square that entire side length, and I had to use FOIL or box method or the pattern of perfect squares to expand that, and then I just solved the equation that I get. So not so bad. I didn't have to actually like factor or do quadratic formula or anything like that because the x squareds cancel out, so it's actually pretty easy to solve. All right, let's go to number 10. Find x. Assume that segments that appear tangent are in fact tangent. Okay, if that's true, then we have a whole bunch of things that we know, right? We know that this length has to be the same as that length. We know that this length has to be the same as that length. And we know that this length has to be the same as that length. Well, if that's true, this is 9. Okay, and if that's true, this section is 16. And if this section, let's highlight it so we can see if this is 16, and this whole thing is 26, well, we know what that is. That's got to be 10. So if that's 10, then x is 10. And that's all there is to it. Easy peasy. So remember that that's based on the congruent tangent theorem, which is just that when you have segments that are tangent to the same circle and they intersect, those segments have to be congruent from the intersection point to the circle. Intersection point to the circle, intersection point to the circle. So x is 10. We didn't even actually have to find 9. It was irrelevant. All right, there's all the chapter 10 study guide questions. Enjoy. Hope to see you guys next time.